system, whether that's an energy system or bioeconomy system, and we use analyses to make sure that bioenergy is sustainable. And today I'm introducing our new model, which we developed basically because we have the primary aim of developing a research tool that enable the assessment and comparison of sustainability of different bioeconomy projects, bioenergy systems, feedstocks, technologies, and supply chains. So essentially, we wanted to develop a tool that would allow us to assess sustainability of bioeconomy and bioenergy projects, which, as you know, can be very varied and strange and large and or small things. So our primary objective to do this was basically to analyze. We wanted to analyze the sustainability credentials of our Supergen Bioenergy Hub case studies, which we'll introduce a bit later. But also we wanted to have a mechanism to basically assess the sustainability of all the projects also funded by Supergen. So that was our primary objective. But in building this tool, we also wanted to give it flexibility in that other people can hopefully use it to analyze the sustainability of their projects, however large or small or whatever focus that their project has. So today I'm going to introduce you to our new tool. And essentially, this is the model architecture of our tool, which I'm going to talk you through. It looks complicated here, but I'll try and make it as simple as possible. So if we start at the top at number 1, essentially we started off thinking, okay, what is sustainability? Sustainability of a project is basically the accumulation of all the impacts and benefits of all linked activities and processes along a value chain. So there's all sorts of things and activities taking place within a value chain, bioenergy value chain, and there might be impacts and benefits throughout. So sustainability is somehow balancing all of those. So depending on what your project is, whether you're focusing on just the feedstock, whether you're focusing on technology or process, or whether you're focusing on a whole value chain, there's all sorts of different steps that are included in bioenergy and bioeconomy projects. So for example, if you are doing a whole systems project, you will have some kind of feedstock at the beginning that might be grown, mobilized, harvested, that might be transported, lots of steps take place. That raw resource might be converted into a more valid fuel, might be into a gas or a pellet or whatever it may be. More steps might take place, and eventually that might be converted into a energy or into a product or into a chemical. And then after the use of that vector, the more steps might take place to, for example, get rid of the waste materials. So there's all sorts of different steps, and our aim was to basically analyze what are the sustainability issues that could take place across all these different steps. So if you go down to number 2 there, we basically identified a large number of sustainability issues. We tried to identify an exhaustive list of all the issues that could take place where the sustainability slants. So for example, issues related to the feedstock production, related to transport, processing, conversion, etc., etc., etc. So our first aim was to talk to stakeholders and gain a very large list, build a very large list of sustainability issues which we think are important. After we got that large list, we sat down with our stakeholders again, and number 3 there on the bottom left, we basically developed a sustainability framework. So taking all those issues and putting them within a framework where we could work with. And the framework we came up with had kind of 4 layers. We had a category, sustainability categories, which were in high level issues related to people, issues related to development, issues related to natural systems, and issues related to climate change. And within each of those categories, there were sustainability themes. Within each of the themes, there were sustainability indicators, and at the very lowest resolution, within each indicator, were different issues. So for example, we have one of our categories is climate change, one of our 4 main categories. And within the climate change category, there is a theme called emissions. Within the emissions theme, there's an indicator called land use change. And as an example, the issues within that indicator, we have direct land use change and indirect land use change. So that's our sustainability framework which we came up with. But how the model works is essentially we've got this large number of sustainability issues, and the user identifies right from the off which of these issues they want to include in their assessment, what they think is relevant, what they think is not relevant, and every issue that they think is relevant will contribute to the sustainability calculation process. We then get the user to basically identify what the 2 scores, what they think the sustainable benefit is and what they think the sustainability risk is, and that will hopefully come more apparent, more clear as I go through this presentation. So basically, you identify which indicators are relevant to your project. You basically highlight what the potential risk is and what potential benefit is. And then there's embedded in each of these issues a sustainability rating. Sustainability rating is quite important because some issues are more or less important to sustainability. For example, when we spoke to our stakeholders, we kind of assessed and said which issues are most important. For example, emissions were quite high up. That's quite an important issue. There are other issues which are also important, but maybe less so than that. So we had a sustainability weighting framework. So sustainability calculation is basically an assessment of the scores provided of the risk and benefit and a weighting factor. And we calculate a sustainability score from that, which I'll come to in a bit. Our model has a further step also where we're able to map through the model how your project kind of map against the UN Sustainable Development Goals. So for example, how will your project benefit each of the 17 SDGs, or maybe risk achieving each of the 17 SDGs. So that's basically our high level modeling architecture of the model we've developed. Going back to our framework, as you can see on the right there, there's some logos, some of them quite famous. So these are the sorts of places we looked at when we were developing our framework of indicators. So in total, we have 4 categories I've already mentioned: people, development, natural systems, and climate change. Within each of those high-level categories, there are 16 sustainability themes, 38 indicators, and a total of 126 sustainability issues. And that's quite good because it provides a really broad net to analyze sustainability with, but it also makes it more complicated because as you'll find, when people ask, is your project sustainable, they normally want to know whether it's a black or white answer. And when you have asking 126 different answers, you might get 126 different answers. So that's another theme that has emerged. But our model is able to look at sustainability across these 126 issues if you want, and model sustainability. An example of some of the topics we covered. So this doesn't go down to the issue level, it goes down to the indicator level. So for example, in the people category there, we look at health, livelihood, society, and indicators related to those. In the development category, we cover things such as the economy, technologies, or land utilization. In the natural systems category, we look at land, air, water, and all things related to that. And within our climate change category, we look at the governance, climate change, carbon and emissions, and the energy system. So this is basically the sorts of issues that we've included in our model. And beyond this, there's also a further column there on the right we've not fit on this slide, the issues one, which is obviously won't fit because we've got 126 of those. You can find that in our literature. So basically, how does it work? So as I said, you go down our list of 126 issues and you identify which of those are applicable to your project. You also then confronted, we tried to keep this as simple as possible. We could have very easily, being academics and liking funky and complicated models, we could have gone down a very complicated process. We thought we'd keep it very simple. So once you've identified whether an issue is relevant to your project, you are asked basically to select a sustainability risk score of what extent the risk you think may be. For example, land use change. Is there a high risk, low risk, medium risk of land use change as a result of your project? And the same for benefit. Is there a high, low, medium, etc. risk for land use change for your project? So this, for each issue, there is a potential for a risk and a benefit. There might be certain issues where there's no risk and there's a benefit, or vice versa. But more often than not, there is a potential risk and potential benefit, and those may be different. So we come up with a lot of indicator scores, which the user calibrate into the model by calibrating that. And then built within the model, there's a weighting. So each of our issues has a weighting, which is developed through our stakeholder engagement process. You can read our supporting literature, which I'll come to at the end of this, which basically describes how we came to those. And then the resulting output from a model is sustainability scores. And these are index values. So they represent degrees of sustainability of risk and or benefit. So these are quite cool because they allow you to look at the varying performance within a project, to see where the sustainability risk is and where the benefits are within a project, allows you to compare between projects. So it allows you to see what's going on in your project, where you need to concentrate to mitigate the risks, or where you could concentrate to maximize the benefits. But there's a bit of a warning: these sustainability scores, I think they have limited external value. For example, a sustainability score within our model, which basically says that your sustainability score for emissions is X, cannot be equated in the real world as being an X unit of emissions. Or likewise, our sustainability score for jobs cannot be equated to creating X jobs. So it has a limited external value, but within the model, it's really good at highlighting and mapping what the sustainability performance of your model is. I'll explain that a bit further as we go through. Sustainable Development Goals. So I've kind of highlighted also that we kind of link to the SDGs. There were 17 SDGs, Sustainable Development Goals, developed by the United Nations, and they cover all sorts of sustainability issues across the whole suite. And within each of these 17 SDGs, the UN have a multitude of separate targets. So for example, within each SDG, there'll be 20 separate targets. So what we've done is we've gone through all of these targets and we've highlighted where the potential links are between bioenergy sustainability and the SDGs. And that's been quite a cool process, interesting process, because as you can see with the end values on the right there, we've kind of highlighted that bioenergy projects or bioeconomy projects have the potential to influence every single one of the SDGs. And I think that's more so than any other renewable technology. So that's quite a win for bioenergy if you're positively influencing each of these SDGs. So what this kind of quite messy diagram basically highlights all those linkages. So for example, if you are doing something sustainability good, if you're having a sustainability benefit for your project, you might have a knock-on effect to helping a country progress towards achieving its SDGs. And we have output results within our model that indicate how that takes place. But our primary output from our model are these sustainability maps, and they're quite simple to understand. You get two sets of maps when you calibrate the model. On the left there, you get a sustainability map, which is basically a radar on all the spokes there, and each one of those represents a different sustainability indicator. And on each one, there is a red and a green. The red obviously for risk and green for benefit. And it basically highlights the scale of risk and benefit of your project. For example, you can see here the bottom right there, about 5 o'clock, techno-economics. For this project, which is calibrated, there's a potential risk there highlighted, which far exceeds the green for techno-economics, which means there's a perception of a greater risk there for techno-economics. That's how it works. You kind of map on the same diagram what your risks and benefits are, and lets you look at where the areas you need to concentrate. On the right is basically the same data, but it's the balance. So for example, where you've got a really large spikes, green or red, there's a really imbalance or real emphasis between there being an overall risk or an overall benefit. You have to be a bit careful, because if you've got certain cases where the risks and benefits are close together, then the balance will obviously cancel each other out. So you need to look at both maps in conjunction with each other, but it is a really useful tool. For example, again, looking at the 5 o'clock there on the radar graph, techno-economics is something where you think, oh yeah, this is a major risk for my project. What we're going to do to try and improve the sustainability through that. So these sustainability maps are quite visually powerful tools to map the sustainability of what you're doing, which is slightly more interesting from an academic analysis point of view, is the actual output sustainability scores. So for each level, each resolution of our model, whether there's a category, a theme, indicator, or issue, we have different sustainability scores. And this is quite interesting when you look at sustainability around. In the beginning, I talked about sustainability not being a black and white issue, sustainability being very much a trade-off of different things, especially when you're asking 126 different questions. There are going to be areas where you're not going to achieve well, and there are going to be other areas where you achieve really well. But if you look in isolation on the far left there, your category column, you've got your 4 categories: people, development, natural systems, and climate change. And next to that, you can see 4 green blocks. That basically demonstrates that this particular project that we've modeled, there's going to be a sustainability benefit for people, development, natural systems, and climate change, which on the surface looks absolutely great. And you could take that away and say, yes, my project is sustainable. But this analysis, this research tool is quite cool and interesting, because if you look deeper within the resolutions, you can actually see what's going on under the surface. For example, if you look right down in the development section, you look at the technologies, you look again at the techno-economics, you can see there's big reds there. So even though there's identified quite a large risk there, this project will probably cost a lot: capital costs, operational costs, etc. That's a potential risk to the project, and that's something that may be a stumbling block to sell your project. But if you look at it in the round, and if you can use modeling like this to make more nuanced assumptions. So for example, if you can justify those costs of techno-economics, you can see the wider benefits that are provided to people, to infrastructure, to the bioeconomy, to emissions, etc. So it allows you to look at sustainability at these different resolutions, and it allows you to justify some of the risks that you might be taking sustainability-wise, but also allows you to identify where some of the leading benefits are. For example, in this particular case, you can see in the climate change category there at the bottom, in the governance, there's particular there's particularly large numbers there, as in there's particularly progress, for example, towards achieving climate change targets. So it allows you to see where your project is contributing and where the potential risks are that need balancing. And if you have particular risks, for example, in this case, technoeconomics, you can kind of balance those out by saying, okay, if we are willing to take on that risk, there are benefits to other areas, which kind of makes that argument a bit easier to make. And the next bit, the output here from our model, is the SDG map. So this basically works the same as the maps before. This presents in two. On the left there, you can see it's a simple 17 SDGs listed down the different boxes, and then they're simply turn color, red, green, or grey. Red where we think there's an overall impact to the SDG from your project, green where there's an overall benefit, and grey where we think that particular project does not influence that SDG. And as I said before, each of the SDGs is made up of lots of individual targets. So there's potential for your project to help certain targets within an SDG and hinder other ones within an SDG. And that's kind of reflected on the radar graph on the right. So you can see, for example, SDG 12 there. Overall, there's a benefit to the SDG, but there are certain targets within SDG where there may be, your project may be detrimental. So it's a case of how you can use this as a valuable tool to highlight how you're benefiting SDGs, as a further tool to look at where the risks are. How can you update your project, mitigate actions, change things to make your project more sustainable and to help achieve the SDGs more widely. So this is my final slide before I pass on to my colleague. So basically, our model is an open access tool available now via the Supergen website, and there's a little bit.ly link there, you can find it. We've also got a guidance manual, which is also in the same location, which basically takes you step by step of how to use it. We're soon to put a YouTube video online, which basically will talk you through how to use it. And we've also just had a paper accepted, which basically demonstrates our research tool in action, and how we've modeled the sustainability of the Supergen projects as well. So essentially, we think we've created quite a nifty model here that allows you to map sustainability of your projects to essentially identify the risks, to mitigate those, and identify the benefits to hopefully maximize those. And I'll pass it to my colleague now, Miriam, who's going to demonstrate what we've actually done within our case studies.
Excellent. Thank you, Andrew, for the introduction to the model. I will now talk a bit more about how the model works for the Supergen case studies. As some of you might be aware, we published it's now a couple of years ago, a report on the Supergen case studies, which have been in the center of the Supergen Bioenergy Hub research we did across the different topic groups. Andrew, can you move to the next slide? I think we have to do it that way. You're in control. Thank you. So the Supergen Bioenergy Hub case studies, there are 6 of them, and they look into different types of bioenergy systems, looking into different feedstocks, conversion technologies, and end vectors, and using a range of different really kind of like approaches. And these also have been developed together with stakeholders from policy, industry, and academia to focus on some case studies which might be of interest in the UK context. Some of them maybe around particular challenges, or to understand if they're actually feasible or if they're not feasible for the UK context. Next slide, Andrew, please. Yeah, that's the link to the report we published a while ago. If people want to have a better understanding about what's in the case studies and the description of the case studies. Next slide, please. So Andrew has fantastically built in a tool into the model where people actually can look into the case study assessment using the tool, which allows you to, on a kind of like really straightforward base, understand how the case studies perform around their sustainability. And that sits, if you then download your own tool, under the SBG case study tab. And you then can just by clicking on the case studies see how each case study performs. Next slide, please, Andrew. Okay, I'll just pick out to give you kind of like an example on getting a bit more into detail how the model actually works. I picked the first case study, which is a hydrogen fuel cell case studies using energy crops. And I just want to use that particular case study to point out how the results of the model can be used and what they actually tell you about the project you analyze. So that's just kind of like as using one example we have ready made for you to look at. So as you see on the left-hand map, the sustainability map, you have a lot of green and red spikes there. And if we look at the benefits first, you can see that there are benefits around jobs and skills, around partnerships, infrastructure, innovation, climate action, and counterfactual consideration. And but at the same time, obviously, we have risks. These lie around the infrastructure, biomass mobilization, efficiency. So that's kind of like conversion efficiency and techno-economics. And obviously, these are specific to this case study you look at and how you score the risk and the benefit for each issue. And you see already that there are kind of like quite some overlaps between some of the issues. So, for example, with the infrastructure requirements, that case study has a high benefit, but that also has a high risk, for example. And that then leads to the right-hand map where we put the scores for the balance, which looks quite different to what you see on the left hand, because as Andrew said, kind of like you might have issues where you have a high benefit and a high risk, and in the summarized balance, it might look like, oh, there's not really any issue around a specific aspect. So if you look at the balance, we keep still a benefit from jobs and skills because there hasn't been quite a risk to it. Same with energy access and the replacement of fuels. But then if we look into the map in terms of risks on the balance, suddenly you see much clearer that there might be a health and well-being risk, that there are risks around the efficiency, which also had been a risk before with a smaller benefit. But there are also risks about the energy system performance and the efficiency and water use. And that's quite helpful to have these two maps to really understand where benefits and risk lies, and also to then identify where is the system performing really well, but where is actually an issue where you might need to mitigate some of the risk. Okay, Andrew, if you could go to the next slide, please. So that's just kind of like an overview if we would put the 6 case studies next to each other in terms of the risk and benefit maps. And you can see that the profiles of each case study is quite different, even though there are some indicators or benefits and risks which are quite similar, because in the end we talk about bioenergy and there are common benefits and risks. But it also shows that bioenergy is not just bioenergy, that the variety of different systems in bioenergy also present different risks and benefits you can achieve. And that is, I think, a really good tool to actually understand what your project can deliver and where you need to make sure you're not accelerating any negative impacts, or where you want to accelerate actually positive impacts. Andrew, if you could go to the next slide, please. Thank you. This is the balance map. And that's also quite interesting because you see what you kind of like would expect from bioenergy projects, that you have really good benefits in terms of fuel replacement, of job and skill development, obviously around energy access, but you see common risks also for some of the projects around the economics and the efficiencies, but also some around kind of like more land, water use focused risks. Okay, to the next slide, please, Andrew. And if we then look at the scores from the different projects, you get quite a different picture for the different projects. And obviously, what I have to point out here, presenting it in a table like this is kind of like comparing oranges to apples, and that's where people need to be careful if projects get compared, because as I said before, bioenergy is different, and different systems have different benefits and risks, and that needs to be kept in mind if you communicate the results of, for example, sustainability assessment. And some of the case studies, as you can see, for example, score negative in the categories of themes, and some score really high in for example, the indicators and the issues. This does not mean that, for example, case study 1 is worse than case study 2. That just means that case study 2 has in some aspects, really high benefits and lower risks, and case study 1 might have in some aspects high risks. This does not mean you shouldn't do case study 1. This means that there are issues you need to be careful about and look into and try to actually mitigate the risks and see how you can work against these risks to avoid them, and how you can actually then also ensure that you maximize benefits. And that's a really good tool, because there might be options where you can't optimize your system and where you have to consider that there are trade-offs between the different indicators and between different aspects within your system, but the model actually helps you to understand where they lie. So where are you kind of like top risks, where are your top benefits, and then you can work on that to maximize them or to mitigate them in a way. And I just pulled out another table below around the categories to show you that actually all of the case studies, of the Supergen case studies, have some negative scores in some of the categories. And again, as I said, that doesn't mean you shouldn't do the project, because lots of the categories with negative scores are around techno-economics and the cost of bioenergy systems, for example. And that is then much more a question on, okay, how can we actually deal with challenges around cost, around techno-economics, to make projects more feasible and more beneficial. But it also shows that, for example, for investors or decision makers, okay, there might be a high cost to a project, but they're all kind of different co-benefits which might have non-market values, which need to be considered in that concept. So that you shouldn't stop a project just because it's too expensive, for example, but also consider what co-benefits can it deliver to society, to specific sectors, and so on. Okay, Andrew, next slide. I think, yeah, that's me. So we now have some time for questions. If I could ask you to switch on your camera and unmute yourself when you ask your question, and also give a quick introduction of your name and your affiliation, please. But I think there's already something in the chat. Maybe we start with that one, Andrew. That's the question from Oliver Broad, if you might want to have a go on that question first. So if people rather want to put their questions into the chat, that is okay as well. We pick them up there. But if they want to actually speak out their questions, so then just raise your hand and we will pick up your questions. Okay, Andrew, do you want to pick the question from Oliver?
I'm just reading it. Sorry, Oliver.
I'm happy to voice it if it's helpful.
Oh, please.
Yeah, please go ahead, Oliver.
So my name is Oliver Broad. I'm affiliated to UCL, Institute for Sustainable Resources. But the question really, Andrew, is just about the numbers, and Miriam's presentation about the case studies kind of rings the bell of the question again. It's sort of across all of the categories, how do the numbers compare? Like, how are you supposed to read the different levels that you get for different categories across categories? So how do you compare one category to another? How are the numbers derived inside of the model beyond the user just choosing high, medium, or low levels of risk or of benefit? And how do you interpret them in terms of one compared to the other, and their consistency across the different categories that you've come up with, just to try and understand a little bit how, whether each element needs to be looked at individually to kind of look at the cost and benefit, or whether you can derive some kind of information like on a whole project basis, and how that works a little bit. Thank you.
Okay, I guess the first thing to stress is that they're like index values, as in they have no unit. unless we give them a unit. They have no unit, so they're only relevant within the model itself to compare. So within each category theme indicator, those numbers are like they're normalized against each other. So for example, your numbers at your category level have been calculated as an accumulation of all the different weightings and scores at each level below that, if that makes sense. So it's probably easier if you read our guidance document where I've got all the calculations listed out there, instead of me getting tongue-tied now. But if you want me to talk to you afterwards, having read that, I'm happy to talk to it.
I'll look through the documentation and have a look. The second part of the question was just you just said that they were normalized. Do you consider a baseline in any of your analysis? What are they normalized against? So it's a cost or a benefit or a risk or a benefit against doing nothing or against what?
There is no threshold, as in this is what you need to exceed. There is no threshold. They're basically normalized on a scale against each other. So for example, if you select all the 126 issues, for example, the scores will come out on a scale of the highest to the lowest, if that makes sense. So if the lowest number you identify, that means essentially that's the issue which has been identified as the most risky of all your 26. So it's basically a ranking scale against itself.
Maybe to add to that, Oliver, so yes, you have to score each issue individually first, but you also have the opportunity to say if one of the issues is not relevant for your project, you can actually switch them off. So you have a choice on what you want to switch off and what you want to switch on. It's also a question about your knowledge about certain issues. So, if for example, you have no idea about the techno-economics or specific costs, then you can switch them off and say like, okay, I exclude them from my assessment. But then obviously you need to, you will see on the output, okay, they're not included. But obviously you need to be transparent around that as well to say like, okay, I only assess a specific category. So you could, for example, say like, if you're just interested in the people category, you could just use that category as an assessment to say, okay, I'm interested around more the social aspects of that. There are some issues in there as well, which are kind of like alarm flags. For example, things around labor rights, slavery, child labor, and things like that. So if you would say like, oh, there's a high risk in my project doing that, everything would be influenced by that, because then that would tell you, okay, I shouldn't do that because there are massive issues around how a project is run, and nothing can be sustainable, which, for example, has slavery or child labor in that. So, and a lot of or not a lot, but the issues were based on scientific knowledge as well. So where we kind of like can say we have a good knowledge and understanding on how they would perform and how they wouldn't perform, or where the risk lies. Okay, I hope that helps a bit. Good. We have a next question from Aline Jensen. Aline, if you could come on, please.
Hello. Oh,
Aline, yeah, hi.
Sorry, my camera is. Oh,
yeah, you're very bright. Oh, you're facing it. Excellent. Hi, Elaine.
I like to have effects. Yeah, sorry, I missed the beginning. I had trouble joining. Firstly, only because of what you were just saying, Miriam, about child labour and so on. This isn't just for developing countries, though, is it? This is to be used anyway. Okay. So my second question. So I'm in Wales. Welsh government brought out their carbon budget can't remember when it was. Oh, it was from 20 to 25, and there is nothing really in there about bioenergy. So I've been on their case about bioenergy, and we're having dialogues with them. And one of the things they want is evidence over the benefits of things like miscanthus, and they want. Really, I think what they could do with these case studies. So I've given them the Supergen, the 6 case studies, and I think it was the second one. Can you remind me what the second one was? Do you remember? Anyway, I think that was the one that they particularly liked, but they want it in a specific, so in a way they'd like me to give them a specific example of how, like an industry in Wales where biomass could be used, maybe embedded into products and so on. and the GHG and the economic benefits of this, which is really outside my limited field of expertise. This tool sounds like it could be really useful. I know that there's a company looking to invest in developing fiberboard in North Wales using miscanthus. And now they must have done their cost benefit, presumably, but I'm guessing they haven't looked at greenhouse gases and so on. And I was just wondering if this is a sort of tool I might be able to use with it. So I'm in discussions with them to find out how much information I can get from them about what the economics are, whether or not we can use that information for Welsh Government. Yeah.
Yes.
Andrew, you want? Yep.
Yes, please use it. I'm happy to work with you to use it if you want. As I said at the beginning, we're using this tool to analyze the case study, those 6 case studies, but also trying to analyze the sustainability of all the projects that Supergen have funded. So it's a paper we're currently working on. We have looked at, I think, 16 scenarios, and I think miscanthus is included in 2 of them. I know one particular, we work with the guys in Aberdeen, who they've done a scenario for us on miscanthus. So we have modelling of miscanthus already. So maybe it's worth having a private conversation after this, to see whether that helps you.
My internet dropped out through that, so I missed a lot of that. And I've got another meeting at 2 o'clock. But I would definitely like to talk about this. Shall I just get in touch, Andrew?
Yeah, definitely, because what Andrew said, we have done some work on miscanthus already and have some kind of like the model set up for miscanthus as well. Obviously, what the model can't do, it can't tell you what the greenhouse gas emissions are, for example. So you would need to have an LCA for that. But what the model then can do, if you know if there are massive benefits or massive risks around the greenhouse gas emissions, you can put that into the model as a risk or benefit score, and then that indicates how that works across the whole system and what role your kind of like emission impacts actually play. So you need to have some kind of like background knowledge around your system performance, and then you can decide on the kind of like risk benefit level it has, and then what the model then does for you is kind of like map everything you want to score within the model, and shows you kind of like the trade-offs and where risk and benefit lies.
Brilliant, thank you.
Okay, next question is Jonathan.
Yeah, hi, John Wagner from Aston University. Well, first of all, I think it looks like a really interesting tool. I mean, assessing with different characteristics is really difficult, and I think you're showing how many different inputs we have to consider. I just wondered about who you think are the main users. Is it just the research community, or is it also companies to demonstrate the sustainability? And associated with that, really the objectivity of the model. So, for example, have you tried to have different people running through that same simulation and seeing how similar or how different the answers can be? Because I think you've already said it's really important that you have the knowledge of these categories. And if you're a company trying to fill it in, you might be overly optimistic maybe about some of these.
Thanks, Jonathan. Good to see you. Yeah, as I said, we've worked with lots of people. When we developed the model, we worked with lots of stakeholders from, I don't know, government, academia, industry, blah, 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 who helped us develop it and played around with a really early version of the model. And we've latterly worked with the Supergen partners, who are admittedly all academic people who've developed these 16 case studies. So we've worked with those guys. But I do admit, if you're really, really cavalier with what you say, the model will churn out answers accordingly. So you need to, yeah, if you're going to use the model privately, it'll say what you want it to say if you're really cavalier with your answers. But hopefully it's developed this transparency there, so people can actually see what you've put in on the inputs. So if you put benefits high with everything, hopefully they can see your workings, and you can't get away with that, if that answers your question. But that is a potential risk.
Yeah, maybe to add to that, my colleague Katie Chong would say all models are wrong, but some are useful. And obviously there's always a risk to kind of like how people want to score or what the assumptions they made. We have used the model with several researchers so far, and interestingly, they kind of like, you're not seeing much variation between how they score the same issues. If it's kind of like similar pathways, bioenergy pathways, obviously if you have very different systems, the scores will be different. And I mean, having used myself a lot, surprisingly, and playing around with that, yes, you need to do some thinking. So it's not kind of like just kind of like click and the answers are there. You need to kind of like think a bit about why do I give it a high score or a low score. As Andrew said, there's the manual which describes each individual issue, provides also literature reference on what kind of like our assumptions to set up the model like this are based, or what kind of like with more explanation for a particular issue if people want to know more about it, or if they want to include it in the assessment, and kind of like a short example describing what that particular issue means, which will help to guide people through the model. Obviously, that's a very long list, but it's very comprehensive. And if you want to be transparent, comprehensive, you have to do that. On the user group, I think it can be used by everyone who is really interested in it. So we try to build something which is not just for nerdy academics who know everything about everything, but that also industry and policy makers can use it. And as I said, what's quite a nice function is that you can switch off some of the or that you can switch off or on issues depending on how good your knowledge is on specific things. And that obviously then the more you switch off, the more it limits your results to what you have looked at. But it also then helps if you switch a lot of things off to maybe just focus around some specific issues where you know there might be a high risk or there might be a high benefit, and to be much more focused on specific things. So you can go very comprehensive and do everything and look at everything and get a very complex picture, but that also then requires from the people to be able to explain that and to interpretate that. But you also can make a selection on the things you might have really good knowledge on or you're particularly interested in.
Yeah, thanks so much. I mean, it would be definitely interesting to also compare to non-bioenergy options and maybe across the different supergens.
Yeah, and the model is set up in a way that it also should work for other things which might not be energy. I mean, things might be a bit more phrased around bioenergy, but if you actually know what you're talking about and understand what the kind of like maybe reference aspect would be in a different system, then that could work as well, or pick aspects which work across all systems.
Thank you.
Okay, excellent. So we have another question from Ritvika.
Yeah, hi, thanks, Miriam. I am Ritvika Sengupta. I work at BASE on biomass sustainability within the biomass strategy team. So I guess I was just wondering on the scoring. So you said that users would score their own projects. I guess I was wondering if you've kind of looked into the subjectivity of that, whether you've compared if there are any differences between how people score themselves, and whether the model does anything to kind of counteract that and check for any bias, I guess.
There's no inbuilt checking process, but if you, it's very okay. We have done quite a few runs of the model now, so we know what good baselines are. So it's very clear when people, as I said before, are cavalier. Those maps look very, very different. And there is no checking mechanism that says you are doing this wrong. We didn't ever intend to have that, and so we wanted to keep it open to all.
And I think it's about how responsible people are in using the model. I mean, you can misuse every model you want to, and if people want to use it for their own interest, that's tough luck for us. And then I might say like, well, the Supergen model says. But if you then look at the scores, if people publish the scores or the kind of like how the model the model results, you would actually spot quite easily, as Andrew said earlier, if everything has a really high benefit score and no risk, you start asking yourself question about the drivers of that person, why it's like this. I mean, from a kind of like common sense, people working in bioenergy, bioeconomy know there are always risks and benefits, and there's a common understanding on kind of like, the model doesn't kind of like bring up surprising results that you would go like, oh, I'm really surprised there's a big benefit around greenhouse gas saving, or that there's a big risk around kind of like maybe indirect land use change. So it doesn't come up with kind of like new knowledge in that sense, and so everything which kind of like would do something really screwed compared to existing knowledge. We would hope that people who then listen to such results would actually pick that out. But obviously, there's never control of how your science and your results are used anyway. So there's only so much you can do to limit, for example, abuse on kind of like how these things are used. But if people use it responsibly, sounds a bit like we should put a stamp on it. Consume responsibly.
Thank you both.
There shouldn't be a problem.
Yeah, there's always that anxiety that you develop something, then you say Supergen say that this is unsustainable in a massive way. That's an ongoing anxiety. So you just have to please use sustainably.
Andrew, there's another couple of questions in the chat. So one is from Anna. The case study seemed to focus on energy crops and municipal waste. Yes, I can answer to that directly. If we have used anything on wood pellets, the case studies, the Supergen case studies, Anna, are focused very much on more novel, not so much common pathways in the UK. That was the idea when we developed the case studies in that round of Supergen, to think about where should bioenergy head in the future in the UK, and what opportunities are there. Obviously, wood pellets are the dominant case study, or the dominant use of bioenergy in the UK at the moment. But there is a lot of knowledge and a lot of published literature around that, so we didn't consider that as a kind of like a future, or from a research point, novel, interesting case study. As you know, we have done a lot of work around the wood pellet to energy combustion electricity case study in the past. So we didn't consider that for that round of Supergen as kind of like a novel research endeavor. That shouldn't stop people to use the model to actually analyze a case study like that.
Okay, to answer Robert, your question, Robert Berry. I think so. So you basically asked, can this? Oh, hi, Robert.
Hi.
So if I'm parallel, you're basically asking, can this project be used over a long time period to look backwards at a project, see whether what you've done is correct? Is that right?
Yeah, sort of. I mean, it's not just looking back, but perhaps to use it as an aid to both tracking and guiding the direction of a project, to get feedback in terms of whether you're moving in the right direction, or ways you could move with a particular project to improve its sustainability. I was responding in part to the observation that there's a degree of subjectivity involved, and yet if you were to retain it, this is just one application, if you were to retain its use within a project, within a cluster of projects where you have a degree of, I don't know, consistency, perhaps even the same person is making these sorts of assessments over a period of time, then you might be able to use this as a way of guiding decision making. I mean, there's a degree of, there's some similarity here to sort of something I've done something with many years ago, something in the area of sort of multi-effect decision making, multi-factor decision making, decision theory. And so that you could use it as an ongoing tool to help you guide the project and get feedback, and both help you then document what you did, why you did it, what happened. So just an observation, just a thought.
Thank you. Yeah, and I agree. You can use this as a tool instead of looking back. This is, what is the sustainability of my project now built? You can use it. What's the sustainability of a project I might build, and how can I change my design, or how can it evolve over time? For example, if you're, as you said, if you're building a project over a long time period, if you do this at different time steps through that time period, and your greatest risks are identified as X, then surely you can mitigate that by taking action as you go forward, and that will, the whole evolution, that whole sustainability map will evolve, I guess, if you put R&D or money or technologies into certain things rather than on another area.
Yeah. Thank you. It's really interesting. Thanks.
Thanks, Robert.
Okay, I can't see any more questions in. So hang on, something has come up. No, that is. People need to leave. Okay. Okay. I can't see any other questions in the chat. I can't see any raised hands. So and we're almost at the hour anyway. So I think that gives people for the next meetings a five-minute break to actually get a drink and have a kind of like stretch their legs. At least it does it for me, which is great. So
you can access the model through that link. It's open access online, and then also the tool, the guidance thing, document is in the same place. But likewise, if you want any help, just email us, and we're happy to. Yeah, it's an ongoing process.
Certainly will want some help.
Yeah, we will also include the link in the next Supergen newsletter. So if people haven't signed up to the Supergen Bioenergy Hub newsletter, do it now. It will be communicated on LinkedIn, Twitter, and so on. As Andrew said, you can contact us if you have any questions. We will put the presentation slides and the recording from the presentation also online on the Hub website, so people can rewatch things if they want to. As Andrew said, he will also prepare a small tutorial video explaining people step by step how to use the model. The manual is already online. I warn you, it's a very long document, but a lot of just kind of like explaining the different issues, which is quite helpful. And yeah, if people have any questions, just let us know. And for now, I just want to thank everyone for joining us for today. I've seen on the participant list a lot of people who have been involved throughout the process, developing the model from the very first day when we started talking about it. So massive thanks to all our stakeholders, colleagues, and friends who have helped us working on the model and developing it and getting it to that point. If people have any recommendations on how to change things, improve things, or have any critique, feedback, it's always welcome, because we're scientists, we like to be challenged. And otherwise, I wish you all a nice day, a nice afternoon, stay safe and healthy, and use the model, because it's a brilliant tool.
Yeah.
Okay, thank you everyone for joining. Okay, thank you.